Moving to iron removal, you can see I changed the word now. It was disinfection before, now I call it purification. And iron has to be removed in a way that you first oxidize the water, then the iron will be oxidized from iron 2 to iron 3, and then it will combine with the air, with the oxygen, and it will precipitate. So that is kind of the pre-treatment. Here, up here, just by running through these small pebbles here, it will oxidize, and then you can filter. It will sediment in the bottom here, and then it will filter through stones. These are small stones, and then you get clean water here. So that is a simple iron removal plant if you have that problem. Arsenic, some of you have arsenic in your village. There are different ways to treat that. Both arsenic and fluoride. Yeah, some of you have fluoride also, yeah. For some reason, because fluoride and arsenic are very different chemicals actually, but for some reason they share the same treatment methods actually. Yeah. You can use coagulation, flocculation. You add some coagulant. It could be aluminium sulfate, which will, where the aluminium will form aluminium hydroxide, and it will form some flocks like small, some kind of precipitate, and that precipitate will grab the arsenic or grab the fluoride, and then it will precipitate to the bottom here. That is the principle in both in the household version and in the village plant here. You can see here you add the coagulant. You may need to add some base also to change the pH, but in some cases you do the same in here. You do this. This is the one we made. Some students made it in West Bengal here for arsenic. They mix it in this container, and then they filter it either through some sand in a plastic bucket or sand in a clay pot. Here, this is a fluoride method where they are pouring it in, stirring it, and then sedimenting, and you get the clean water. And this is a big plant here. So this is one of the measures, flocculation. Another method is the adsorption. You can have some different materials. For example, for fluoride, we use bone char. This is animal bones which have been charred at very high temperature, so you get kind of a ashes kind of product, which is very good at adsorbing the fluoride. Otherwise, you can use aluminium oxide, which is also a product that is pretty cheap. So you just fill it into a column here, and then you run the water in, and then it will be adsorbed here. So with time, it will get saturated. So with time, it will no longer adsorb anymore. But for some time, it will work here. In the case of arsenic in West Bengal, it's often combined with iron. So first we have to remove the iron before, otherwise the iron will quickly coat all the. This is the adsorbent here, aluminium oxide in this case. So first we have a sand filter. This is for a household solution here, where there's a sand filter in one, then it runs into the aluminium oxide, and then it runs out here. So in the household version, it looks like this: one for sand, one for aluminium oxide, and in the community version, it looks like this. Again, sand is here, aluminium oxide is here. So this is all. Both these designs are developed by students from DTU in our project in West Bengal. This is another DTU student, Jane, who went to Thailand together with Augusta, who's sitting here, looking at fluoride some time ago. And this is a fluoride filter with bone char, animal bones that are supplying water for a temple in Thailand. Right, we're coming to the end here. This is kind of, you could say, a summary for the whole water supply thing here. And first, the importance is to get water closer to people. again, is the thing. More important to have more water than to have cleaner water. First of all, you need more water to clean your hands and so on. So you get water closer to people, you look at more water, so you have enough. You need at least, say, 20, 25 liters. Then you have enough for washing hands. If you have 20, 25 liters per person per day. And then in the end, you look at cleaner water. All of this you should look at, but in this priority here. Should choose the most appropriate water supply system. Again, as I said before, look at the sources you have available. Try to find the best source, the cleanest, the easiest, and find the best water supply system. And then treat the water only when necessary, because it takes some effort to treat it, and it is maybe it can be difficult to maintain. And then look at the textbook. You can also, as I said, look at the slides here. There is some formulas that I hit when showing this, but the formulas are somewhere in between. And then the textbook for design here.